Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 25 Probability. We'll be discussing all the concepts with examples and solve questions from exercise 25A. Ready? Let's begin. Probability. Probability is a word we are all familiar with. Probability means nothing but chance. Okay. Today it will rain or it won't rain. These are chances. Now you can see some examples here. When you play a Ludo game, you use a dice. So throwing a dice, there are equal chances for getting any of the number. Can you tell that I want 1? Will the dice listen to you and give you a 1? No, right? When you roll this die, you can get 1, 2, 3, 4, 5 or 6. When you draw a card from a deck of 52 cards, there are equal chance of getting any of the cards. It can be Jack Diamond, it can be a 6 spades, it can be a 2 clubs, it can be 6 hearts. Any of this, you cannot predict it. When you have a well shuffled deck of cards, you can predict any number. When you toss a coin, can you tell that I need head, so you should give me head? No, right? You can get head or a tail when you do a proper toss. If you take a case of a football match, I like Argentina. Does it mean Argentina wins the game? And I am saying Argentina will win. Is it a chance? There are equal chances for Argentina to win or the opposite team to win. Yes? So, since I like a team, it doesn't mean it will win the game. So, let it be a football match or a cricket match. There are equal chances for both the teams. Okay. Same is the case when you toss a coin, there are equal chances. So, the chance is what probability is. If you have a bag of which is filled with balls, I'm having 7 black balls and 3 red balls. Is it necessary that when I pick a ball from this bag, since there are maximum number of black balls, I will be getting a black ball. It can either be a red ball. Yes. Or I'm having 7 black balls, 3 red balls, 5 white balls. Is it necessary that I will be getting a white ball? No, right? I can get a red ball, I can get a black ball or a white ball. So it doesn't mean if there is maximum number of one colored balls, it doesn't mean that you will be getting that ball. The chances of getting this ball, that is a black ball, is higher, but it doesn't mean you will be getting a black ball. You can either get red or you can get black. In a case you are having 5 red balls and 5 black balls. Here there are equal chances of getting red balls and black balls. There is no maximum or minimum. Both the balls are in equal quantity. Okay. Understood? Let's now understand probability in detail. First, we'll be discussing a few terms. Random experiment. What is experiment? We have been doing experiment in physics and chemistry labs. What we do there? For a result or for a proof, we do something and only after the result is obtained, we believe it. Okay. So that is what an experiment is. Now, what is this random experiment? For example, you know that when you add milk, water, sugar and tea powder, you will be getting a tea. Okay. You can make tea with milk, water, sugar and tea powder. Now, if in place of tea powder, I am giving coffee powder, what happens? Milk plus water plus sugar plus coffee powder. This will give me coffee. Now, what is the difference here? Just by changing one, you are getting a different outcome. But you know that thing, the outcome is fixed. Using all these, you can only get a tea. Milk, water, sugar and tea powder will always give you a tea. There is no change. The outcome is predicted. That is, outcome is always the same. Okay. When you are giving input this, the outcome will be this. It is sure for it. Okay. So, if there are more than one outcome, here in both these cases, the outcome is just a single outcome. Okay, it will not change. But when I toss a coin, just imagine tossing a coin. What happens there? So when I toss a coin, I can get either a head or a tail. There are two outcomes. So a random experiment is one in which there are more than one outcomes. Okay, let's define random experiment. An experiment is called a random experiment if it satisfies the following two conditions. The first condition is it has more than one possible outcome. In these cases, there is only a single outcome. But when it comes to tossing a coin, what happens? There are two outcomes. So when there is more than one possible outcome, we call it a random experiment. The second condition is it is not possible to predict the outcome in advance. Can I say that by tossing this coin, I will get head? Is it sure? No, right? There are equal chances of getting head and tail. In that case, we call it a random experiment. So what are the examples of random experiment? You cannot take this as a random experiment because here the outcome is always predictable. When you mix milk, water, sugar and tea powder, the outcome is going to be tea. You cannot get coffee by mixing all these. Yes. So the outcome is a single outcome and it is always fixed. But when there are more than one outcomes, you cannot predict which is our outcome. Okay. It is not well defined. In that case, we call it a random experiment. So the examples are first, tossing a coin. Then throwing a dice. While throwing a dice, what are the outcomes? When you throw a die, you will be having 6 outcomes. Either you can get like this, that is 1, or you can get 2, or it can be 3, then 4, 5, or it can be 6. So there are equal chances for getting all of these. It can be 1, 2, 3, 4, 5, 6. While playing Ludo, can you predict that I am going to get 3 this time? Can you say that? Is it sure? No, right? There is equal chances of getting any of these. You cannot say that unless you are just keeping it like this. When you throw a die or roll a die, you will surely have equal chances of getting this. So both of these are examples of random experiment. Clear? Next term is sample space. What is sample space? The set of all possible outcomes of an experiment is called sample space and is generally denoted by the letter S. Got an idea? With the letter S, we denote sample space, and the sample space includes all the possible outcomes. They are always represented within flower brackets. To represent a set, we will be using flower brackets. Now, when I take the case of a dice, in case of dice, what are the outcomes? I can get 1, I can get 2, 3, 4, 5 and 6. There are equal chances. So, inside this set, I'll be writing all the possible outcomes. So, this is the required sample space when rolling a dice. Okay, when rolling a dice, this is the set of all the possible outcomes, and here you have the sample space S. Now, number of elements in the sample space is denoted as N of S. Okay, which means this is the total number of outcomes. Here, when you roll a die, the total number of outcomes will be equal to 6. Total number of outcomes is represented by N of S, and N of X will be equal to 6 in this case. Now, when you take the case of tossing a coin, tell me what should be included inside this flower brackets? Yes, you will be having either a head or a tail. So, either you should get this head or you should get this tail. No other outcomes are possible. Can you get that, like it can be in the middle? So, if I toss a coin, can I get this way? No, right? Either it should stand like this or this way. So, two possible outcomes, head, tail. Head is represented by H and tail is represented by T. So, these are the two possible outcomes. Now, tell me what is N of S? Total number of outcomes. In this case, total number of outcomes will be equal to 2. Understood what is sample space? The sample space is a set of all possible outcomes. Here, rolling a die, this is a set of all possible outcomes. Tossing a coin, this is a set of all possible outcomes. And the total number of outcomes are given here. Okay, let us take the case of coin toss. So when one coin is tossed, there are two possible outcomes, which is head and tail. Okay, equal chances of getting head and tail. Now how is the sample space represented? In this case, one coin when taken, the sample space will include the two possible outcome, which is head. The first outcome is head and the second outcome is tail. So in this case, the sample space will be equal to inside the set, inside the flower brackets, head, comma, tail. Now I will tell you another case. I am taking two coins. Okay, I have two coins and I am tossing both the coins. In that case, is it necessary that in both the coins you should get head? No, right? Either you can get head on first coin and tail on second coin, or tail in the first coin and head on the second coin, or both tail. Anything is possible. So how many outcomes will be there in this case? You are taking two coins. So this is your first coin and second coin. So the first case is getting head on both the coins. Head, head. Next is in the first coin you will be getting a head, and on the second coin you will be getting tail. Okay. Then tail on the first coin, head on the second coin. Tail on first coin, tail on second coin. So these are the four possible outcomes. So how to represent this? This is represented as, here the sample space. So here we are taking the case of two coins. The sample space is represented as inside the flower brackets, within common brackets, first one, head, head. This is how you represent head, head. Okay. Then next is head, tail. This is how you represent head, tail. Next, tail, head. This is tail, head. Then tail, tail. This is how you represent tail, tail. Got it? Understood? So here you are getting four outcomes. N of S is equal to 4. 4 possible outcomes. Total number of outcomes is equal to 4. Okay. This is a case of coin toss with two coins. Now tell me, if I have 3 coins. I have 3 coins. What are the possible outcomes? When you have 3 coins, you will be having first coin, second coin, third coin. Okay? First coin, second coin, third coin. First case, getting head on all the coins. Okay? Second case, first coin head, second coin head, third coin tail. Next case, first coin head, second coin tail, third coin head. Next case, head on the first coin, second coin tail, third coin tail. So these are the 4 cases in which head appears on the first coin. So when head appears on first coin, you will be getting 4 cases. Next 4 cases is when tail appears on the first coin. Okay, tail appears on first coin. In that case, tail, head, head. This is possible. Then tail, head, tail. This is possible. Tail, tail, head. This is possible. Tail, tail, tail. This is also possible. So what are the total number of outcomes? 1, 2, 3, 4, 5, 6, 7, 8. You have 8 outcomes. Now tell me the sample space. Sample space includes in the flower bracket starting head, head, head. Next, head, head, tail. Next, head, tail, head. Then, head, tail, tail. Head, tail, tail. Okay. So, these are the 4 cases with head appearing on the first coin. Next, tail appearing on the first coin. Tail, head, head. Then, tail, head, tail. Okay. Next, tail, tail, head. And the last one, tail, tail, tail. Tail, tail, tail. So tell me, what is the total number of outcomes? We have 8 outcomes. So this is a case with 3 coins. Okay, 2 coins or same outcomes will be there when a coin is tossed 2 times. Okay, 2 times the same coin is tossed. In that case, first time, second time. In place of first coin, second coin, you will be having first toss, second toss. Again here, 3 coins or coin is tossed 3 times. First time, second toss, third toss. You will be having 3 options. Okay. Clear? Clear with this? Now I'll give you a simple technique. To write this, to write the total outcomes, a simple method is here. When coin is tossed 3 times, first write head 4 times, then tail 4 times. Okay. For the second column, head, head, tail, tail. 2 times head, 2 times tail. Again 2 times head, 2 times tail. Okay. Next, head, tail, head, tail, head, tail, head, tail. So this is how easily we can write the outcomes when 3 coins are used. Next, if it is 2 coins, again same thing. Head, head, tail, tail. Head, tail, head, tail. So you can get the outcomes easily. You won't be getting the same outcomes again. Clear? This is the case with coin toss. Understood? Let us understand the rolling of dice. When a dice is rolled, how many outcomes do we have? We have 6 different outcomes. First, it will be like this. Second, 2. Third, 3. Fourth outcome, 4. Fifth outcome, 1, 2, 3, 4, 5. Sixth outcome, 6. Okay. All these are the possible outcomes when a die is thrown or a die is rolled. Okay. So now tell me the sample space. Sample space includes 1, 2, 3, 4, 5, 6. Okay. And n of s, the total number of outcomes is equal to 6. Now take the case we are having 2 dice. When these 2 dice are thrown, what are the possible outcomes? Here, what will be there? There will be a combination. When 1 appears on the first die, okay, 1 appears on the first die, the second die can have 1, it can have 2, it can have 3, it can have 4, it can have 5 or 6. So 1 appearing on the first die, all these are possible. Okay. Now, when 2 appears on the first die, 1 can appear on second, 2 can appear on second, 3 can appear on second, 4 can appear on the second, 5 can appear, 6 can appear. Okay. Next, 3 appearing on the first, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4 on the first and 1 on the second, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Next, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Next, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So these are the possible outcomes when 2 dice are thrown together or you are rolling the die 2 times. Okay. So this is the required sample space. How many outcomes do we have? What is the total number of outcomes? N of s. Just count. You will be having 36 outcomes. Now a simple technique just to find the total number of outcomes. When here we know 6 is the total number of outcomes when a dice, that is a dice is taken, you will be having 6 possible outcomes, right? So 6 raised to n is the formula to find the total number of outcomes, where n is number of dice or number of times dice is thrown. Okay, just take this example. When the die is thrown just once or the number of dice is equal to 1, then n of s, total number of outcomes will be equal to 6 raised to 1, which is 6. When 2 dice are taken or 2 times the dice are thrown, in that case, what was n of s? N of s is equal to 6 raised to 2. What is 6 raised to 2? Or 6 square, that is 36. Here we are getting 36 outcome. N of s is equal to 36. Now tell me, if the number of dice is equal to 3, in that case, how much do we get? You will be getting 6 raised to 3. If it is 4, then 6 raised to 4. Similarly, in the case of coin also, you can do the same thing. In case of coin, you had only 2 outcomes. Okay, when one coin is taken, you have 2 faces, which is head and tail. Therefore, the formula will be 2 raised to n. For coin, n of s will be equal to 2 raised to n. So, when n is equal to 1, you will be getting 2. When n is equal to 2, 2 coins are taken, 2 square 4, 3 coins are taken, 2 cube 8. Okay, clear? Next case is tossing a coin and rolling a dice together. Together you are taking a coin and a dice. So now here what is the sample space? Let us find. When head appears on the coin, 1 can be there on the dice. Head on the coin, 2 on dice. Head on the coin, 3 on dice. Head 4, head 5, head 6. Okay. Similarly, when tail appears on the coin, 1 on dice, tail 2, tail 3, tail 4, tail 5, tail 6. So these are the possible outcomes. What is n of s? Total number of outcomes. N of s is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N of s is equal to 12. Okay. Now let us understand the basic things about the playing cards. Hope you all know. You all have played with these cards, I'm sure. Now let's understand this. Here, how many cards are there? Here total of 52 cards are there. Okay, a pack contains a total of 52 cards. In this 52 cards, you will be having A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K, Jack, Queen and King. Okay, then you will be having the shapes. Now note the shapes: diamonds, hearts, spade and clubs. Okay, then what you have to note, the color of the cards. Here you have red cards and black cards. What is the total number of red cards? Red cards. Half of these are red cards and half of these are black cards. So 52 divided by 2, 26 cards are red in color and 26 cards are black in color. Okay. What is the total number of A cards? That is A's. How many A's do we have? How many A's do we have? Counting 1, 2, 3, 4. So Ace of diamond, Ace of heart, Ace of spade, Ace of clubs. Okay. So 4 Ace cards we have. Similarly, you have 4 2s, 4 3s, 4 4s, 4 5s. All the number cards will be there 4 times. Okay. How many face cards do we have? With each shape, diamond. Diamond face cards are 3. Heart face cards are 3, spade face cards are 3 and clubs face cards are 3. So total in this deck you will be having 12 face cards. Okay. Next what you have to note? Each shape. How many diamonds do we have? How many diamonds? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Diamond. Each number will be having a diamond. Okay. So diamond cards, 13 diamond cards are there. Similarly, hearts. 13 hearts will be there. Then spade, again 13. Next, clubs. Clubs also 13. So these are the basic things you need to understand about cards. In a deck of 52 cards, red will be 26, black 26. Then number cards. Each number will be there 4 times. Next, after that, the shapes, diamond cards, 13 diamond, 13 heart, 13 spade and 13 clubs. Okay, basic things you understood? Clear? What is an event? An outcome of a random experiment is called an event. Very simple. An event is something that happens. For example, take the case of coin toss. So in case of coin tossing, getting a head. This is an event. Okay. Event E is equal to getting a head. Then when you roll a dice, getting an even number. If I say getting an even number or getting a prime number. Then getting 1, getting 2. All these are events. Okay. Event is something that is an outcome of a random experiment is called an event. Now you need to understand what are equally likely outcomes. When you take the case of coin toss, you have two outcomes, head and tail. There are 50% chances of getting head and the same 50% chance of getting a tail. So this type of an outcome we call equally likely outcomes. Okay. In the case of rolling a die, there are equal chances of getting 1, 2, 3, 4, 5, 6. Any of this. Okay. So any of these 6 outcomes can appear. Therefore, this is again an example of equally likely outcome. Now consider a case. I have a box. In this box, I am having 8 black balls and 2 red balls. Okay, just use a logic. Which ball will I get when I put my hand inside this and pick a ball? Is it necessary that it should be a black or red? Is it equal chance? Is there any equal chance of getting black balls and red balls? Here in this bag, maximum number is for black balls. There are maximum number of black balls, which means the chances of getting black ball is higher. Yes, compared to the red balls, there are only 2 red balls. So we can say that there are chances of getting red balls, but still the maximum chances are for getting black balls because the bag contains maximum number of black balls. In this case, we cannot call this equally likely outcomes. If the case was 5 black balls and 5 red balls, equal number of black and red balls, in that case, we can call it equally likely outcome. But here we don't have equally likely outcome because the chance of getting black balls is higher. Okay, if there are equal chance of getting both the outcomes, we call it equally likely outcomes. Understood? Let us study how to measure probability. What is probability? Probability of an event is the likelihood of it happening. Okay, if in an experiment we are denoting the total number of outcomes as n of s and the number of favorable outcomes as n of e. What is e? E is the event. Okay, e is the outcome. Then probability is given by number of outcomes favorable to e divided by total number of all possible outcomes. Take our common example which we take always, coin toss. Okay, coin toss, my event is getting a head. Getting a head is my event. Okay. So what are the outcomes? The sample space is head comma tail. Head comma tail. What about the event? The event is getting a head. Then event is just heads. T cannot be taken. T is getting a tail. So the event is getting a head. Then what is n of s? Total number of outcomes 1, 2. What about n of e? Favorable to the event. The outcomes which are favorable to the event. Event is getting a head. The outcomes favorable to the event, n of e will be equal to just 1. Okay. Here the formula is number of outcomes favorable to the event denoted as n of e divided by total number of outcomes denoted by n of s. In this case, you will be getting 1 divided by 2. Okay, n of e is 1 and n of s is 2. Clear? So 1 by 2 is the probability of the event. That is probability of getting a head is equal to 1 by 2. Next, another case. The event here is getting a tail. Getting a tail. Now tell me what is P of E? Sample space is same. Possible outcomes. Next, favorable outcomes to the event. Just T comes here. N of S is equal to 2 and N of E is equal to just 1. In this case, again, P of probability of getting a tail will be equal to 1 divided by 2. They are equally likely. Therefore, the probability of both the events happening will be same. Got it? Got an idea? So, this is how you can measure probability. P of E is equal to N of E divided by N of S. Let us understand what empirical and classical probabilities are. First, empirical probability or experimental probability. From the word itself, it is clear that when the probability is based on an actual experiment. Let's perform an experiment. Here I have a coin. I am going to toss the coin. Okay. First case, I got a tail. Next, again I am tossing the coin. Now I got a head. Tossing again. Again I got a tail. Once more performing the experiment. I got a tail. Okay. Now when you take the estimate. Here I got tail 3 times and I got head 1 time. So what are the possible outcomes here? We have tossed the coin 4 times. 2 possible outcomes are either it should be head or it should be tail. Now in this case, out of this 4, tail appeared. That is probability of tail is equal to 1, 2, 3. 3 by 4. What about probability of head? 4 times the experiment was performed and head appeared just 1. So this is an experimental probability. Is it necessary that always I should get the same? Now again I am performing the experiment. Okay. That is I am tossing the coin. 4 times I am going to toss the coin. First time I got a tail. Tossing it again. I got head. Again tail, head. Okay. Tail, head. Now, here 4 times the experiment was performed. Probability of getting tail was equal to 2 times. Therefore, 2 by 4 or that is equal to 1 by 2. Now, what is the probability of getting head? Will be equal to again 2 by 4, which is 1 by 2. The probability has changed. In this case, when the experiment was performed, that is based on the experiment and the conditions, it is changing. Again, if I perform, I can either get like 1 times tail and 3 times head, or all the 4 times I may get head, all the 4 times I may get tail. So all these are possible. This is based on the experiment. Based on the experiment, I am getting all these values. Now next comes the classical or theoretical probability, which we are going to use in this chapter. Okay. When a repetition of an experiment can be avoided for calculating the exact probability, the probability so obtained is called classical probability. That is, we are not repeating the experiment. Here, when experiment is kept performing, what happens? The result changes. Yes, the result is not fixed, but we can tell that the chance of getting a head when a coin is tossed is equal to 1 by 2. Okay, without performing the experiment, we are just telling that the probability of getting head is 1 by 2 because it is sure there is equal probability of getting head and tail when a coin is tossed. Then the probability of getting a tail is equal to 1 by 2. There are equal probability of getting tail as well. Okay, this is what classical or theoretical probability is. Here it is based on experiment. Here just we are concluding it. Okay. Elementary events and complementary events. What are elementary events? That is only one favorable outcomes. An event has only one favorable outcome, then it is called elementary event. For example, getting a head. Getting a head. There is only one favorable outcome. That is, the answer should be you should get a head. Okay. So this is an elementary event. Or next, what is a complementary event? When it comes to complementary event, there are 2 outcomes. That is, either getting it or not getting it. Now, first is, let us take the event is getting a head. Okay. Next, not getting a head. Not getting a head means it is getting a tail. not getting ahead. So these two are complementary events. So here, not getting ahead, you represent this event by E bar, okay, not E. When you have these two, the probability of getting ahead, P of E, and the probability of not getting ahead, P of E bar, will always be equal to 1. So, the total probability will be 1. That is the sum of probability of get that event and not that event. That is, the event is not getting ahead and the event is getting ahead. When you take the sum, you will be getting 1. So, these type of events here, E and E bar are complementary events. Another example, when you toss or when you roll a dice, in that case, I am asking you, getting a number greater than 3. This is your event. Then what is the complementary event? The complementary event will be getting a number not greater than 3. You cannot say less than 3 because in that case equal to 3 won't be included. So you have to say getting a number not greater than 3. Just understand this. Not greater than 3 and less than 3 both are different. Less than 3 means only you will be having 1 and 2. But when it comes to not greater than 3, it includes 3 as well. Equal to 3 is also possible. So these are elementary events and complementary events. Next is impossible events and sure events. Okay, impossible events means if the probability of an event is equal to 0, then the event is called an impossible event. Rolling a die and I am asking you, the event is getting 8. Okay, you have to get 8 when a die is thrown or it is rolled. In that case, rolling a dice and getting 8, is it possible? You have only 6 digits on the dice. 1, 2, 3, 4, 5, 6. Getting 8 is not possible, which means it is an impossible event and therefore you will be having number of outcomes favorable to the event equal to 0 and the total number of outcomes in this case is equal to 6. 1, 2, 3, 4, 5, 6. Number of outcomes favorable to this event is equal to 0. Therefore, the probability of the event will be equal to N of E by N of S and that is 0 by 6 which is equal to 0. This is an impossible event. It is not going to happen. Or I am asking you to find the probability when dice is thrown and you have to get a number greater than 6. Greater than 6. This is your event. Is it possible? You can get 6 but you cannot get a number which is greater than 6. Therefore, in this case also the probability will be equal to 0. This is again an example of impossible event. Now next is sure event. If the probability of an event is equal to 1, the event is called certain event or sure event. You will always get the probability that is equal to 1. Okay, if the event, in any case, you will be having probability lies between 0 and 1. Okay, either the probability should be equal to 0 or it can be equal to 1 or any number between 0 and 1. Understood what impossible event and a sure event is? For example, for sure event, we have taken an example like milk plus water plus sugar plus tea powder. What is the outcome? The outcome is tea. This is a sure event. If all this combination, the combination of these are made, then surely you will be getting tea. Is there any change? No. This is a sure event. Okay. Understood? So what is impossible? What is sure event? Let us take an example. Find the probability of getting ahead when a coin is tossed. When coin is tossed, tell me the sample space. S is equal to head, tail. Total number of outcomes. N of S is equal to 2. What is the event? Here the event is getting ahead. Getting ahead is the event. That is getting heads. Next, number of outcomes favorable to the event N of E. Here, Just one outcome is favorable to the event. Then the probability of the event will be equal to number of outcomes favorable to the event divided by total number of outcomes, which is equal to 1 by 2. Okay, so this is the required probability of getting a head when a coin is tossed. Next example, in a single throw of a dice, find the probability of getting a number. First one, greater than 2, less than or equal to 2, not greater than 2. First, let us take greater than 2. Here, what is the sample space? Sample space includes 1, 2, 3, 4, 5 and 6. Total number of outcomes is equal to 6. First case, greater than 2 is the event. Greater than 2. Okay. Greater than 2 is the event. So, what are the numbers greater than 2? You cannot include 2. 3, 4, 5, 6. 3, 4, 5, 6. Number of outcomes favorable to the event 1, 2, 3, 4. 4 outcomes are favorable to the event. Therefore, N of E is equal to 4. Now tell me what is the probability of the event? P of E will be equal to N of E divided by N of S. That is 4 divided by 6. Reduce. We have to reduce it to the smallest fractions. You will be getting 2 by 3. So the first part, the probability is 2 by 3. Now the second part, the event is less than or equal to 2. Less than or equal to 2. How much do we get? Less than or equal to 2, which means less than 2, 1 is less than 2 or equal to 2. Here we have 2. Okay, 1, 2. Number of outcomes favorable to the event is equal to 1, 2. Okay, then the probability of the event will be equal to number of outcomes favorable to the event divided by total number of outcomes. What is N of E? In this case, N of E is equal to 2 and the total number of outcomes N of S is equal to 6. Reducing, you get 1 by 3. What about the third case? Not greater than 2. Not greater than 2 means less than 2 and equal to 2 can be included. Okay, it should not be greater than 2. Not greater than 2. In this case, N of E will be equal to, what are the possible outcomes? 1 is less than 2 and 2 is equal to 2. Okay, therefore, same outcomes we have 1, 2. N of E is 2. P of E will be equal to N of E divided by N of S and that is 2 divided by 6 equal to 1 by 3. Okay, again you are getting 1 by 3. Third example, this is a question that appeared for ICSE Board Exam 2020. Each of the letters of the word authorizes is written on identical circular disc and put in a bag. They are well shuffled. If a disc is drawn at random from the bag, what is the probability that the letter is? First case, a vowel. Second, one of the first 9 letters of the English alphabet which appears in the given word. And the third, one of the last 9 letters of the English alphabet which appears in the given word. Okay, so let's take the first case. Here, what is the total number of outcomes? It can either be A, U, T, H, O, R, I, Z, E, S. Okay, sample space S is equal to A, U, T, H, O, R, I, Z, E, S. Okay. Now tell me what is the total number of outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is the total number of outcomes. Next, here we got N of X. In the first case, we need a vowel. The event is getting a vowel. What are the vowels appearing here? A, U, O, I, E. All the vowels are appearing in this word. Okay. A, U, O, I, E. Okay. Number of outcomes favorable to the event is therefore equal to 1, 2, 3, 4, 5. Okay. Then we have the probability P of E is equal to N of E by N of S, and that is equal to 5 by 10, which is 1 by 2. So the first answer is 1 by 2. Next, the second one. One of the first 9 letters of the English alphabet which appears in the given word. Which are the first 9 letters? A, B, C, D, E, F, G, H, I. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the first 9 letters. Now, take the word. A comes. Yes, A belongs to the first 9 letters. U and T does not belong. Then H belongs. O doesn't belong. R doesn't belong. I belongs. Z doesn't belong. Then E belongs. Okay. Therefore, here the set event is equal to. You will be having A, H, I, E. Okay. Number of outcomes favorable to the event is equal to 1, 2, 3, 4. Okay. Therefore, the probability of the event is equal to N of E by N of S, and that is 4 divided by total number of outcomes 10, which is equal to 2 by 5. Next, the third case is one of the last 9 letters of the English alphabets which appears in the given word. Which are the last 9 letters? Z, Y, X, W, V, U, T, S, R. Counting 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the last 9 letters of English alphabet. Now check. U, okay, then T, then O is not there. What about R? R is appearing. Then S is also appearing. So we have the 4 letters. In this case, event E is equal to 1, 2, 3, 4. And again, Z is also appearing. So include Z. So the 5 are the possible outcomes. U, T, R, Z, S. N of E in this case is again equal to 5. Then what is the probability of the event? P of E is equal to N of E by N of S, that is 5 by 10 equal to 1 by 2. Here again you are getting 1 by 2. Clear? Now let us solve problems from exercise 25A. Here we have the first problem, question 1 of exercise 25A. A coin is tossed once. Find the probability of first question getting a tail, second not getting a tail. So let's do the first one. When you toss a coin, what are the outcomes? That is, first we have to write the sample space. S will be equal to. We have 2 outcomes. Either it should be a head or it should be a tail. So on the coin, you will be either getting a head or you will be getting a tail. Is there any other options? No, right? When you toss a coin, you will be, when you open your hands, you will be having either a head there or a tail. Okay. So 2 outcomes are there. What are they? Head and tail. Okay. So we can write number of outcomes here will be equal to 2. This is a total number of outcomes. Okay. And the sample space includes head and tail. Now what is the event? Here the event E is getting a tail. Okay, getting a tail. That is T. So this is the outcome of getting a tail. Okay. Then number of outcomes in which we are getting tail, just 1 outcome. N of E will be equal to 1. Okay. Then we can find what the probability is. Probability P of E is equal to N of E divided by N of S. What is N of E? N of E is the outcomes that are favorable, and N of S, it is the total number of outcomes. Here we have 1 as N of E and N of S is equal to 2. Therefore, 1 by 2 is your answer. Okay. So 1 by 2 is the probability of getting a tail. Now the second one, we have to find the probability of not getting a tail. P of not getting a tail. Okay, if you don't get tail on the coin, what should it be? It should be a head. Only one option is getting a head when it is not a tail. Okay, therefore we can write getting a tail. So not getting a tail, probability of not getting a tail is equal to the probability of getting a head. Okay. Probability of not getting a tail is equal to probability of getting a head. What is the probability of getting a head? We know probability of getting a tail is equal to 1 by 2. Here again the sample space includes head and tail. Sample space includes head and tail. Now n of s is again the same, that is 2. Event is not getting a tail. Not getting a tail. How many outcomes will be there? Just head. If it is not tail, then it should be head. So n of e. What is n of e? N of e will be equal to 1. Only possible outcome is getting a head. Okay. Then what is the probability of the event? Here the event is not getting a tail. Okay. P of e will be equal to n of e divided by n of s, and that is 1 divided by 2. So in both these cases, that is the probability of getting a tail is 1 by 2 and the probability of not getting a tail is also 1 by 2. So the probability of not getting a tail means getting a head on the coin. Clear? Coin tossing is clear? Okay. Let's move on to the second problem. Question 3 of exercise 25A. In a single throw of a dice, find the probability of getting a number. First one, greater than 4. Second, less than or equal to 4. Third one, not greater than 4. Okay. When you roll a dice or when you throw a dice, what are the outcomes? You know how a dice look like? This is a dice. It will be in the shape of a cube. It will be having 6 faces. And on 6 faces, there will be 6 numbers, right? So here, you will be having 1. On this face 2. On this face 3. Here 4. Then, in the back face, let us say it is 5. And in the front face, you have 6. Okay. So, this is a 3D figure. Just imagine, you have 6 faces. On the 6 faces, you have 6 different numbers from 1 to 6. So, what are the sample space? Sample space S will include getting 1 or 2 or 3, 4, 5, 6. Can any 2 of this come together? When you roll a die, on the top face, there will be only a single number. Out of these 6, any one will be your answer. Okay. So, first question here is, before that, what is n of s? Total number of outcomes. Total number of outcomes is equal to 1, 2, 3, 4, 5, 6. 6 outcomes. So, we got n of s is equal to 6. Okay. Now, the first question. In the first question, we need greater than 4. So, here the event E is greater than 4. A number that is greater than 4. Okay. What are the numbers that is greater than 4? Can we include 4? 4 is not greater than 4. Okay. So, 4 cannot be included. Then, you will be having just 5 and 6. So, here in the event E, we will be having a set containing 5 and 6. 5 and 6 are the numbers which are greater than 4. Okay. So, we got the event. So, what is n of E? Number of outcomes favorable to the event. Here the event is a number that is greater than 4. Number of outcomes that is favorable to the event includes 2, that is 5 and 6. So, you will be getting n of E is equal to 2. Now, we can easily find what the probability is. Probability of the event will be equal to number of outcomes favorable to the event divided by total number of outcomes. N of E divided by N of S. What is N of E? N of E is equal to 2. And N of S is equal to 6. 2 by 6. Can you reduce this? Yes, right? So, here dividing the numerator and denominator with 2, you will be getting 1 by 3. Okay. So, 1 by 3 is the probability of getting a number that is greater than 4. Probability of getting a number which is greater than 4. Clear? Now, the second one. You need a number that is less than or equal to 4. in the event, which numbers can be included? A number that is less than or equal to 4. 1 is less than 4. 2 is less than 4. Then 3 is less than 4. Can I put 4 here? Yes, right? Why? It can either be less than 4 or it can be equal to 4. So 4 should be included. What is N of E? Number of outcomes favorable to the event will be equal to 1, 2, 3, 4. 4 outcomes are favorable to the event. Okay. N of E is equal to 4. We have N of S is equal to 6. Probability of event, and here the event is getting a number that is less than or equal to 4. P of E will be equal to N of E divided by N of S, which is 4 divided by 6. Cancelling with 2, you get 2 2s are 4 and 2 3s are 6. Can you cancel this further? No, right? So here we have prime numbers cannot be cancelled further and 2 by 3 is your answer. Okay. Now the third one. What is the event? Not greater than 4. So here the event is not greater than 4. Not greater than 4 means it includes numbers which are less than 4 or equal to 4. It should not be greater than 4. Greater than 4, we know the numbers are 5 and 6, which means the numbers should not be 5 and 6. All other numbers are possible. Which are the other numbers? 1, 2, 3 and 4. It can either be less than 4 or it can be equal to 4. Okay. So, the event E will include 1, 2, 3 and 4. So, number of outcomes that is favorable to the event will be equal to 4. Then the probability of this event, that is probability of not greater than 4. Probability of the number being not greater than 4 will be equal to N of E divided by N of S, which is N of E is 4, N of S is 6. Cancelling, we again get 2 by 3. Okay, so the probability of getting a number that is greater than 4 is equal to 1 by 3. Probability of getting a number less than or equal to 4 is equal to 2 by 3. Probability of getting a number which is not greater than 4 is also equal to 2 by 3. Understood this problem? So this is a problem that is dealing with the dice. Okay, you will be mostly getting problems either related to the coin or with the dice or related to cards. Okay, be very careful. You have to take the sample space properly and the event mentioned. You should get the correct values only in this. Okay. Problem number 3. Question 5 of exercise 25A. So here this problem is related to the cards. From a well-shuffled deck of 52 playing cards, one card is drawn. Find the probability that the card drawn will be. The first question, be a black card. Second, not be a red card. Third, be a red card. Fourth, be a face card. And fifth, be a face card of red color. Okay. So, how many cards are there? There are total of 52 cards. So, the sample space will include 52 cards. N of S will be equal to 52. Total we have 52 cards. First question, be a black card. Here the event is card being a black card. Now tell me, we have studied about the cards. How many cards in this 52 will be black cards? We know the cards are of colors black and red. Okay, equal number of black and red cards will be there. If the total card is 52, then half of the cards should be black and half should be red. Then what is the total number of black cards? Yes, 26 cards. Okay, number of black cards is equal to 26 cards. So here this includes spades and clubs. Okay, now what is the number of outcomes which is favorable to the event? Here the event is card being a black card. How many outcomes? 26 outcomes are favorable to the event. So 26. Okay, we got N of E and N of S. What is the probability then? Probability of event will be equal to number of outcomes favorable to E divided by total number of outcomes. That is 26 by 52, which is 1 by 2. Just by using the logic, you will get the answer. Half of the cards will be black and half of the cards will be red. Then the probability of getting a card which is black in color is 50%. That is 1 by 2. Okay, let's move on to the second part. Not be a red card. Okay, here the event is not be a red card. If the card is not in red color, then what will it be? There is only two options. Either it should be black or it should be red. If it is not red, then it will surely be a black card, right? This will surely be a black card. How many number of black cards are there? 26. So, number of outcomes favorable to the event will be again equal to 26. Same case, if the card is not red, then it should surely be a black card. N of E will be equal to 26. We can find the probability. P of E will be equal to N of E divided by N of S. That is 26 by 52. Again the same answer, 1 by 2. Okay, half of the cards when taken, you will get a card which is not be a red card. Okay. That is, it is a black card. Now the third part. Be a red card. This is again easy. I think you already got the answer. Here the event is, it is a red card. How many cards are red in color? 26. So N of E is equal to 26. Then what is the probability of the event? P of E will be equal to N of E divided by N of S. Again 26 by 52, which is equal to 1 by 2. Now the fourth one. Be a face card. What is a face card? When you check the cards, you will be having a jack, queen and king cards. Okay. So jack cards, there will be diamond in heart, then clubs and spades, right? Okay. So in all these shapes, you will be having jack. Similarly, in all these shapes, you will be having queen. And in all these shapes, you will be having king. Okay. So, jack face card, there are 4 jack face cards. Queen, 1, 2, 3, 4 and king, 4. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 face cards we have. Okay. Therefore, here the event is be a face card. So, N of E will be equal to, these are the face cards. N of E will be equal to 12. Then the probability of the event will be equal to number of outcomes favorable to E divided by total number of outcomes, which is 12 by 52. Cancelling with 4. 4 3s are 12. 4 13s are 52. Okay. So 3 by 13 is your answer. Now the fifth one. Be a face card of red color. Okay. Here we have 12 face cards. In this face cards, we know diamond and heart cards will be in red color. Club and spade will be there in black color. Okay. Then how many cards, how many face cards are in red color? It is given. Be a face card of red color. Okay. It should be red in color and it should be a face card. So here when you check this 3 diamond, that is the jack diamond, queen diamond and the king diamond, jack heart, queen heart and the king heart. These are the cards. These are the face cards which are red in color. Then you will be getting, here the event is be a face card of red color. You will be getting number of events favorable to E is equal to 6. And then probability of the event will be 6 divided by 52. Cancelling with 2, we get 3 divided by 26. Okay, 3 by 26 is your final answer. Very easy, right? Understood this? Yes. Next, problem number 4, question 6 of exercise 25A. If A and B are two complementary events, then what is the relation between P of A and P of B? Let us take the example of coin tossing. Complementary events mean if one case is not happening, then it should be the other case. Coin tossing, if it is not head, then tail. If it is not tail, then head. Only two options are there. So in that case, we call it a complementary event. Okay. So here, if the probability of A and the probability of B is taken and added together, you will be getting 1. So this is the relation. This is the relation between P of A and P of B. P of A is the probability of the event A and P of B is the probability of event B, given that these two are two complementary events. Just imagine the case of the coins. We know that the probability of getting a head is 1 by 2. Probability of getting a tail is your second event, and that is also equal to 1 by 2. Okay. What is 1 by 2 plus 1 by 2 is equal to 1. So this is an example of an event in which, or that is two complementary events. That is either A here is getting head and B here is getting tail. Just give you an example. Okay. If the probability of happening of an event A is 0.46, what will be the probability of not happening of the event A? If A doesn't happen, then B should happen. Okay. So that means here we know that if it is not head, it will be tail. Okay, same thing. So let us take P of A. The second part, P of A. That is event A happening is equal to 0.46. Then what is the probability of event A not happening? It will be written as P of A plus P of A bar. A bar means the event is not happening. Should be equal to 1. Okay. 0.46 plus P of A bar is equal to 1. P of event A not happening will be equal to 1 minus 0.46. I am taking the 0.46 to the right hand side. What happens when I take something to the right hand side? The sign changes. Here it is positive, it becomes negative. Positive becomes negative. On subtracting 0.46 from 1, what is the final answer? You will be getting 0.54. So, the probability of event A not happening will be equal to 0.54. Clear? So this is it. Problem number 5, question 8 of exercise 25A. In a race between Mahesh and John, the probability that John will lose the race is 0.54. Find the probability of first one, winning of Mahesh, second, winning of John. Okay. This is again an example of complementary events. Here, there are only two chances. The race is between John and Mahesh. Either John should win or Mahesh should win. If John wins, then Mahesh loses. And if Mahesh wins, John loses. Here it is given that the probability of John will lose the race is 0.54. Which means the probability of Mahesh winning will also be equal to 0.54. Yes, is there any doubt? No, right? So here let us take A as the event which is winning of Mahesh. Okay. We know that the event John lost the race and Mahesh winning are same. Okay. Either Mahesh should win or John should win. If Mahesh wins, then John loses. And if Mahesh loses, John wins. Therefore, we have the probability of winning of Mahesh is equal to probability of losing of John. John losing the match and Mahesh winning the match has the same probability. Here it is given that John will lose the match. Probability is 0.54. Therefore, the probability of Mahesh winning will also be equal to 0.54. Okay. Now, the second part, we have to find the probability of John winning. Okay. We'll be having probability of winning of Mahesh plus probability of winning of John will be equal to 1 because we have only two options, either Mahesh should win or John should win. So, when you take the sum of the probabilities, you will be getting 1. Here we already know that the probability of winning of Mahesh is 0.54 plus the probability of winning of John will be equal to 1. Okay, then the probability of winning of John will be equal to 1 minus 0.54. I am taking the 0.54 to the opposite side. You will be getting 1 minus 0.54. What is the answer? The same calculation we have done in the previous question. Yes, you will be getting 0.46. 0.46 plus 0.54 will be equal to 1. So, the probability of John winning is equal to 0.54. Okay, probability of John winning plus probability of John losing will be equal to 1. Yes, 0.46 plus 0.54 will be equal to 1. Clear? Next, problem number 6, question 10 of exercise 25A. In a single throw of a dice, find the probability of getting. You have 4 options, that is either you should get 5, second one getting 8, a number less than 8 and a prime number. Here what is the sample space? Sample space is equal to. You are throwing a dice just once. You will be either getting 1, 2, 3, 4, 5 or 6. Okay. These are the 6 possible outcomes. Now, how much is the probability of getting 5? Here, the first case, the event is getting 5. Okay. Getting 5. What is N of E? Number of outcomes that is favorable to the event. Just one outcome, right? Out of the 6, just one outcome is favorable to E. What is N of S? Total number of outcomes 1, 2, 3, 4, 5, 6. You have 6 outcomes. N of E by N of S will be giving you the probability of the event. Number of events, number of outcomes favorable to the event divided by total number of outcomes, which is 1 by 6. Okay. Out of 6 options, just one is getting 5. Now the second one, getting 8. Here we have 1, 2, 3, 4, 5, 6. Do we have 8? Do you think when you roll a die, you will be getting a number 8? No, right? There is no chance of getting 8. Event is getting 8. What is the number of outcomes that is favorable to the event? 0. There is no outcome that is favorable to the event. N of E is equal to 0. You have the total number of outcomes. N of S is equal to 6. Okay. Then the probability of event will be N of E divided by N of S, which is 0 by 6. What is 0 by 6? 0 multiplied or divided with any number will be giving you 0. So, the probability of getting 8 is equal to 0. Just use the logic. We know that you cannot get 8 on a dice when it is rolled or thrown. Okay. So, getting 8 means either we have to take the sum when 2 dice are thrown, or a dice is taken and twice it is rolled. In that case, when you take sum, you can get the number 8. Clear? Now, the third part, a number less than 8. Here, what are the numbers? 1, 2, 3, 4, 5, 6. Okay. In this event, what are the numbers that is less than 8? All of these numbers are less than 8. So, the event includes 1, 2, 3, 4, 5 and 6. Okay. Therefore, the number of events number of outcomes of the events is equal to 6. Total number of outcomes is also 6. Probability of the event will be equal to n of e divided by n of s, which is 6 by 6 equal to 1. Okay. Now the fourth part, it should be a prime number. Here the event is being a prime number. Hope you all know what are prime numbers. Okay. Here we have 6 options. Okay. In this, which are the prime numbers? 2 is a prime number, 3 is a prime number, 5 is a prime number. We won't include 1 as a prime number. Therefore, in the set you will be having 2, 3 and 5. Okay. Number of outcomes favorable to the event will be 3. Total number of outcomes is equal to 6. Probability of getting a prime number, that is here the event is getting a prime number, will be equal to number of outcomes favorable to E divided by total number of outcomes, which is 3 by 6. You can reduce it. What is the answer then? 1 by 2. Okay. 1 by 2 is your final answer. So that is it. Problem number 7, question 14 of exercise 25A. A single letter is selected at random from the word probability. Find the probability that it is a vowel. Hope you all know what are vowels. We have been studying about vowels from our KG classes. A, E, I, O, U. These are the 5 vowels. Okay. Now you have a word probability. So these are the letters of the word probability. Okay. The sample space will include all these letters. P, R, O, B, A, B, I, L, I, T, Y. If any letter is repeating, still you have to include it in the sample space, because when you pick, either it can be this B or this B. Is there any other letter that is repeating? I is repeating. Either it can be this I or this I. So in the sample space, if 2 times the letter is repeating, you have to include it. Okay. Now, what is the total number of outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Total outcomes is equal to 11. Now, what is the event? The event is letter chosen being a vowel. Okay. Here, which are the vowels? O is a vowel, A, I, and again I. Remember, you should include both the I's. Okay. O, A, I. Number of outcomes favorable to the event. 1, 2, 3, 4. N of E is equal to 4. Then what is the probability? Probability of the event will be equal to number of outcomes favorable to E divided by total number of outcomes. 4 divided by 11. Okay, here 11 is a prime number. You cannot cancel it further. So 4 by 11 is your answer. So 4 by 11 is the probability of getting a vowel. Choosing a vowel from the word probability. Okay. Here we have the last problem for today. Problem 8, question 15 of exercise 25A. Ramesh chooses a date at random in January for a party. See the following figure. Here the figure is given which represents the calendar of January. Find the probability that he chooses. The first option is a Wednesday, second a Friday, or the third one a Tuesday or a Saturday. Okay. So let's do the first one. Here in the January calendar, you can see there are up to 31. Dates are there up to 31. Then what is the number of outcomes? The total number of outcomes, either it can be 1, 2. That is the date which is chosen by Ramesh can either be 1, 2, 3, 4, 5, etc. up to 31. Any of these 31, he can choose a date. Okay. Therefore, the sample space will include all these numbers. S will include all these numbers. 1, 2, 3, etc. up to 31. Okay. N of S, that is the total number of outcomes, will be equal to 31. Now, the first question, here the event is a Wednesday. Okay, here first is a Wednesday, then 8th, 15th, 22nd and 29th. All these are Wednesday. So the party can be on 1st, 8th, 15th, 22 or 29th. Okay. Then here the event includes 1, 8, 15, 22 and 29. What are the number of outcomes favorable to the event? N of E 1, 2, 3, 4, 5. N of E is equal to 5. Then the probability of the event N of E divided by N of S is equal to 5 divided by 31. 31 is a prime number. So we cannot cancel, and 5 is also a prime number. We cannot reduce further. 5 by 31 you will be getting. Now, the second part, the event is being of Friday. Okay. Here, 3rd is a Friday, 10th, 17th, 24th and 31st. All these are Fridays. So, party can be on a Friday. Then, E includes 3, 10, 17, 24 and 31. Number of outcomes favorable to E. 1, 2, 3, 4, 5. N of E is equal to 5. Probability of the event will be equal to number of outcomes favorable to the event divided by total number of outcomes. 5 by 31 again. 5 by 31. Now the third part. A Tuesday or a Saturday. It can either be a Tuesday or a Saturday. Tuesday. Here 7th is a Tuesday, 14th, 21st and 28th. Okay. Then Saturday, or it can be on Saturday. 4, 11, 18 and 25. Here the event E includes the dates 7, 14, 21, 28. Then Saturdays 4, 11, 4, 11, 18 and 25. 18, 25. What is the number of outcomes favorable to the event? 1, 2, 3, 4, 5, 6, 7, 8. 8. We have the total number of outcomes is equal to 31. Probability of the event will be N of E divided by N of S, which is 8 by 31. 8 by 31 is your answer. That is the probability of the date being, the party being on a Tuesday or a Saturday will be equal to 8 by 31. Clear? That's all for today. In today's class, we have discussed all the concepts related to probability with examples and solved many questions from exercise 25A. There are a few more questions which are left, which you can solve on your own. I'll be back in the next session with the next exercise. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.